Hey everyone, welcome back to the Java Full Stack Developer series. Today we are tackling some essential topics that will make your Java coding smoother and more efficient. Debugging in IntelliJ and handling exceptions, whether you are stuck on a bug or dealing with unexpected errors. This video has got you covered. So let's dive right in. First up, let's talk about debugging in IntelliJ. Debugging is like having a superpower that lets you see what's happening inside your code while it runs. It helps you find and fix issues faster. We'll cover breakpoints, debug mode, evaluating expressions, and inspecting variables. So the first, breakpoint. Imagine breakpoints as pause buttons in your code. When you set a breakpoint, your program will pause at that line. Allow you to inspect what's going on. Let's see how to set up one. Alright, so please open your IntelliJ and create some code. In IntelliJ, you can find a line of your code. So before that, we need to write something, right? You need to define a variable named a, assign the value by 5, and another variable equal 10, and you may create a variable for a sum of these variables, and here we can create a method public static in the method named add with two parameters x and y, and in here we just return the sum of these parameters and go back. For the sum, we assign the value by calling method and put a and b to get the sum of these variables. Then we can print out the result to the console. The sum is sum, like this. And now you click in the left gutter next to the line number you want to debug. It should turn red. For example, if you move the mouse here, you can see the red happen here, and when you click on this, you can see that's your breakpoint. Okay, breakpoint, and you will run the program. But here you won't run by click on the play button, but you will click on the debug button here. Okay, the button icon is something like a bug. Okay, you just click on this. Alright, now you see the code is paused here for this line. You can see two tabs here, threads and variables, and a console tab here. You click on the console and see the line to print the sum here is not reached, right? Because we just pause the program at these lines. So you want to the line come into these lines, so you need to press here. You can see on the some button here, you can see the first resume program. If you click on this, the program will continue to the next breakpoint. For example, if you create another breakpoint here and you press this button, the program will run to this. If there's not there's not any breakpoint, the program will go to the end and finish. Okay, and the next button is step over, means that you will move the pause line to the next line. For example, you click on this and you see the break line move to the next line here. And when you step again and you see this line was executed, so you see the sum is 15 on the console like this. So that is the debug mode. Okay, you run with this button, with the debug button here, you are in the debug mode. Next, while you pause, you might want to check the value of an expression without modifying the code. You can right click on any variable or expression and select evaluate expression. For example, you come back to the thread and variables tab and you see the express a equal 5 and b equal 10 and sum equal 15 here. You can right click on this and you choose evaluate the expression, and you can click the button evaluate so you can see the value show here, the result. Or you can run the method here by choosing the add method like this, and you right click on this and you choose the evaluate expression and you click evaluate again and you see the result. But now sometimes the evaluation cannot be executed, so it shows you undefined like this. Okay, so that is how you can evaluate in expressions. Alright, so we'll move next to the handling exception. So exceptions are expected events that disrupt the normal flow of your program, and handling them properly makes your code more robust and prevents crash. Java use try-catch blocks to handle exceptions. You wrap the code that might throw an exception in a try block and handle the exception in a catch block. For example, you can create an example like this. You will because before we use the try catch block, we can do something with this. We will calculate a result by do an operator with 10 divided by 0 like this. So this expression will show you will throw you an exception. So here you will try to print the result here, but for this you can't see the result because the program will be crashed on here before it can show you the result in the console. Alright, so let's run this to see what happened. Alright, you can see you can't see any print, any result in the console, but you see some red light here, exception in thread main, and the exception name is arithmetic exception divided by 0. Okay, this is the name of an exception. Alright, so to to avoid or to prevent the program be crashed, you can wrap this with a try-catch block like this, try-catch, and in here you can put the name of the exception, arithmetic exception, like this, and in here you can print something instead of throw an exception to make the program crash. Error cannot divide it by 0, like this. Alright, you can run it. Alright, now you do not see any error light, so the program not crash again. And yeah, then the exception will be catched here, and you can handle it here to print it out in the console. In some case, in the real program, you can do something like show a pop-up or a message error to the user, so the user can understand what happened with their program, and they can easily to understand the situation to solve it. Okay. Now we will go to some exceptions, some common exceptions. So let's look at some common exception you might encounter. For example, you can see alright, in the you create an array number, and you define, you initialize some element for this array. We have 3 elements in this array, so we can know the length of this array is 3, right? And you try to print an element from its array. An element from the array. If you print the element 0 or 1 or 3, you can see it in the console. But if you print the 4 or 5, so you see this array just have 3 elements, but you put the index over the mark length. So it will show you an exception, and that exception is array index outpower exception, right? Index outpower, sorry. Okay, and let's try this. So now you see the error is happening here. So let's try to use another index like 2. So what you see in here, it doesn't show you the error, it shows you the value of the index 2 from the array number. And the common, very common issue, very common exception you will see many times when you program in, that is the null pointer exception. This error is very popular, very common. Null pointer exception. Okay, you will see it many times. For example, you can create a string equal null like this. And yeah, when you work with a real program, when you actually program something, you can know exactly when a variable is null. Okay, so you need to do something like check if the string is null, so you won't do next to prevent the program crash. But this case we just because we use the try catch block, so we don't worry about the string is null. Here we try to print the string length. Okay, let's run it. Because the string is null, so you can call the method on that variable. Alright, you see, no pointer exception. And yeah, we talk about the finally block. The finally blocks is optional but useful. It runs whether or not an exception was thrown, making it great for closing resources like files or database connections. Okay, you can print something here. This block always run you see the error exception and the block finally. This always runs to make sure that you do the right thing in case an exception appears. And yeah, we go to another thing. Sometimes you want to throw an exception manually or declare that a method might throw one. That's where throw and throws come in. So you can create a method by your own. Public static void check age, and you put a parameter for the age here, and this method will throw an exception in some case. So to do that, you after the in the end of the parameter of the method, you will use the throws keyword. Please note that this keyword has the S letter in the end of the throw. Okay, throw exception like this. And in the body of the method, you check if the age is less than 18. You will throw. In this case, you use throw without the S letter in the end of the keyword, and you throw a new exception like this. You must be at least 18 years old. Okay, and in here you try to check A and you put something greater than 18 like 19 like this. Okay, so you will use the try catch again for this, and catch exception, and in the catch you just show what the error from the error age to string. And let's run it. Yeah, it doesn't show anything because the exception not be thrown. So need to put 17. Sorry about this. Alright, you can see an exception show here. And if you want to see when an exception occurs, Java prints a stack tray. It's like a map that shows the path your code took before the error happened. Understanding stack traces is crucial for debugging. And to see the stack tray, you can call alright, print stack tray like this, and print it. Alright, you can see this is the stack tray. Okay, and you can see, you can click on here, the main.java as the logic, and see from the first point that make the crash. Or you want to go deeper, you can click on the main and see the line that made an exception. And sometimes you build in exceptions are not enough. You need to create your own custom exceptions. Let you define specific error conditions for your application. Alright, you can create a class age exception like this. And any exception in Java must be extended from exception. Okay, and here you create a method. You create a constructor, a exception, and here you put the error message, and you just call the super constructor from the exception like this. And in here, instead of throw a new exception, you will throw an age exception like this. Alright, and that's it for today. We explored how to debug your Java code using IntelliJ handling exception to make your programs more robust. Understand stack traces for better debugging, and even create your own custom exceptions. These skills are essential for writing clean and reliable Java applications. In the next video, we'll dive into more advanced topics to keep building your Java expertise. Don't forget to like, subscribe, and hit the notification bell so you never miss an update. Thanks for watching, and I'll see you in the next time.